Okay, so number 5 says, consider the following measures shown in the diagram with the circle centered at point A. The radius is 3 centimeters and your central angle is 42 degrees. Determine the appropriate major arc length of CDB. Well, we have the minor central arc and minor central angle. So we know here that we could find CB, but that's not what we want. We want this arc, the major arc. So we need this angle right here. Well, we know all we have to do is take 42 and subtract it from 360 and then use the length of the arc formula. So in number 5, the first thing I did is I took 42, subtracted it from 360 degrees, and I got 318 degrees. Then I used the length of the arc formula by taking 318, putting that over 360 and multiplying by 2 pi 3. And I came out with approximately 6.65, or letter D. Okay, so now number 6, it says consider the following measures in the diagram with the circle centered at point A. AC equals 8 inches, and the measure of angle BAC is 7 pi over 9 radians. So now our angle's given to us in radians instead of degrees. So it's saying determine the approximate arc length of BC. So here we have our central angle of 7 pi over 9, and then we have a radius of AC, and we want this arc right here. So we're just going to take that formula for number 6, 7 pi over 9, and put it over 2 pi. So remember, because we're measuring in radians as opposed to degrees, instead of using 360, we're going to use 2 pi. And 2 pi and 360 equal each other. Then we're going to multiply that by 2 pi times the radius of 8, and immediately we can cancel out that 2 pi. So now it's just a matter of multiplying 7 pi over 9 times 8, and you're going to get approximately 9.55, or letter D. Okay, so moving on to number 7. Consider the following measures shown in the diagram with the circle centered at G. The radius is 8 centimeters and the inscribed angle measure AHB is 70 degrees. Determine BA. So what we have here is inscribed angle, that is 70, and we want to find the measure of arc AB. We know that we have this radius as well. Well, here, if you'll notice, our inscribed angle H and our central angle G are intercepting the same arc. So we know we can find the arc here by saying, okay, 70 times 2, which will be 140, and that makes our central angle 140 as well. So now we can just use the length of the arc formula by using 140. So that's what we did with number 7. We said, okay, AB is going to be equal to, or arc AB is going to be equal to 70 times 2, which is 140, which is also going to be equal to our central angle AGB. So we're going to take that 140, put it over 360 times 2 pi radius, and we're just going to multiply that out. Now on this one, we're going to keep pi. If you notice, our answer choices have pi in them, so you don't want to put pi in your calculator. So all I'm going to do is I just canceled out the zeros there and put 14 over 36. Then I cross canceled the 4 into 16, which is 4, and into 36, which is 9, and then multiply 14 times 4, and I got 56 over 9 pi, or letter D. Now, a lot of you asked me about the next problem, number 8. It says, determine the perimeter of the polygon shown. You may assume that any 2 consecutive sides of the polygon are perpendicular. So basically, all I did here is I knew that this top up here would be 4, and the reason why I knew that is because I knew from here to here was 2, and then from here to here was 6, and I mean 4, and then from here to here was 6, and your difference between 6 and 4 is 2. So I knew that going across and opposite would be 4 from each other. So what I did is just said 4 plus 4 plus 4. plus 4 plus 2 plus 6 plus 2 plus 2. And then I added those together, and you should have gotten 26 centimeters, letter C. Okay, now number 9, here it says determine the approximate perimeter of the convex figure shown. You may assume that the figure includes 2 sectors of circles, one centered at point A and the other at C, each with a radius of 5. So I knew that this up here would also be 8, but here we had to find the length of this arc, and we had to find the length of this arc, and this is a central angle, and this is a central angle. So it's almost like they just cut this slice out of a circle in both of these places, and I knew they were going to be congruent because they had the same angle and the same radius. So I just used the length of the arc formula in order to find those. So I just said, okay, 70 over 360 times 2 pi 5 is equal to 6.1. And I had 2 of them, so I multiplied by 2 to get 12.2. So then I just simply added 12.2 to all of the other sides to get 38.2 centimeters. And then the last one, number 10, there was a mistake in number 10. They actually shown you in the figure that one length of the side was 12 of the triangle, but then in the problem they told you that it was 6, so you had to go with 12. So basically the way this should have read was an equilateral triangle and a square both have the same perimeter. If each side of the equilateral triangle is 12 centimeters in length, then what would be the length of one side of the square? So some of you asked about it, some of you just kind of figured it out, but that was the case. So really all you had to do with this one here is just say, okay, 12 plus 12 plus 12 equals 36 because we're finding the perimeter. So then the square, I know I have 4 congruent sides, and I know when I add them they have to equal 36. So I just made a little equation out of it. We have 4x equals 36, then divide by 4 and x equals 9, or C.